Hello, James Flatten here with the Minnesota Space Grant to say a few words about the Minnesota Space Grant's Intercollegiate Challenge for the academic year 2022-2023. Let me share my screen and take a look at the challenge announcement. Okay, so the Intercollegiate Challenge for this year is to do stratospheric ballooning in an eclipse. Unfortunately, there's no eclipse this year, so let's call this a mock eclipse. It turns out, as shown in the lower right-hand corner of this slide, that there is an eclipse that's coming in 2024, April 8th of 2024. It will pass through Mexico, it will pass through Texas, it will pass through Indiana, and up past through Maine. In fact, it misses Minnesota. This is the path of totality. But what I'd like to do is I'd like to challenge you to build something worth flying on a stratospheric balloon, worth flying during an eclipse. And I'm going to pretend that there's an eclipse 1 year in advance of this date. So instead of April 8th, 2024, the real eclipse, we'll have April 8th, 2023, the mock eclipse date. And we'll have the path pass over Minnesota because it's convenient to do so. And the prize for this particular competition will be that I will take your payload and fly it in the real eclipse in 2024, because I'm planning to be at that eclipse with my ballooning team anyway. So with eclipses, you don't get to choose the day, you don't get to choose the time of day. So we'll fly on April 8th, 2023, rain, snow, sunshine, hope for good weather, but we'll do the best we can, regardless of the weather. Okay, so let's step back just a little bit. Let me stop sharing for a moment. What is stratospheric ballooning, or sometimes called weather ballooning because we use weather balloons? Well, basically, as you might expect, weather balloons are the balloons used by the Weather Service. So here is a very short video clip showing the release of a weather balloon recently. In this particular case, the weather balloon was carrying just a single payload. It was a fairly small payload, a student-developed box. The weather balloon in this case was filled with helium, enough helium to make sure it would lift the balloon and also lift the box. And then there it goes. There is a parachute along that line. It was a little hard to see. And this particular payload went up to about 110,000 feet. And then for experimental reasons, slowly came down to 80,000 feet. And then severed the line and came down by parachute. So that's what it looks like to release a weather balloon. On the other hand, what does it look like to be on a weather balloon? Well, when you are at 60 or 70 or 80 or 90 or 100,000 feet, the view is about the same. The sky is black in the middle of the day. You can see the curvature of the Earth, but it can be sometimes obscured by the curvature of the camera itself. The payload, which is hanging from the balloon, is not going to be a particularly steady platform. And so it's sometimes hard to do photography, frankly. But here is a view. And in fact, what I'm going to do is I'm going to go forward to 11 minutes and 24 seconds in this particular video clip. So here is about 10 seconds or so before burst. Notice that it's rotating a lot. So it turns out it's not that easy to do good photography from such a platform. But at the peak of this particular flight, at about 90,000 feet, the balloon burst, and now the payload's going to come back down. So if you're going to do this activity, you need to build things that are tough. They have to be ready for the difficult environment of the stratosphere, and then they have to be ready for the difficult occasion of the re-entry in this case. So photography, that's not the only thing you might imagine trying, but that's one of the first things that comes to mind. And it's a space-like environment, and frankly, it's a space-like view. So that's a little tiny bit about stratospheric ballooning. What then is eclipse ballooning or eclipse stratospheric ballooning? Well, it's just what you think. It's doing this kind of a ballooning activity while an eclipse is taking place, a solar eclipse. So from this perspective, you'll be above the clouds, and hence you could watch the shadow go by underneath you, for instance, or you could perhaps look up at the sun, although that might be hard to do just because you're swinging and swaying. You won't get clouded out So this is always a concern if you happen to be on the ground, is what's the weather going to be like? Will I be able to see the eclipse? The balloons will see the eclipse for sure, but they won't see the eclipse with people on board. There's only payloads and cameras and computers and sensors on board. And so if you are to develop something, we want you to develop something that is worth flying during an eclipse. So you have to think about what is the conditions, and then how might those conditions be different in case of an eclipse, and then develop some sort of a payload capable of surviving this sort of a flight and generating interesting information. Hopefully more than just photography, frankly, information that would be useful to collect during an eclipse. Let's actually take a quick look at what it could look like during an eclipse. So this particular payload, so here's some kind of low resolution photography, because this was actually a video stream to the ground. That's complicated to do. I'm not expecting people to necessarily be able to pull that off. But it's not swinging and swaying very much, just because we had figured out a way to keep it from rotating a lot. It's still swinging and swaying some. And so there's the eclipse shadow moving at about 1,600 miles an hour across the cloud tops away from us. It's just passed over the top of this balloon, and now it's on its way away. And notice some of the time, like right now, the view is interesting, but it's missing the eclipse. So you have to be careful. If you manage to stop rotation, the eclipse might not even be in view at the important time. But of course, if it's rotating too fast, then it's in view and it's gone, and it's in view and it's gone, and you can't really focus on it. So there's a challenge, I guess, is to figure out how to take good video, if you want to concentrate on photography, in the right direction. So what does it look like? As in, what do these payloads look like? Let me just show you a couple of payloads. I have a couple with me. They don't have to look like this. They more or less have to be fairly lightweight. And so this particular payload here has strings on the sides so as to attach it to the balloon above. It's made of styrofoam, so it's not very complicated. It's a cube shape, doesn't have to be, but that's kind of handy. So there it is. It's made of styrofoam, the pink styrofoam that you might see for construction projects. And this particular one happens to have a bunch of sensors in it. So these sensors, this one says UVB, in other words, ultraviolet range B. This one says UVA, ultraviolet range A, and this one says light. So basically, these are 3 light sensors, and they were designed to stick through a slot in the lid, and then the payload was actually designed to hang somewhat at an angle so that it would point toward the sun when it was flying. So this was trying to monitor the light intensity from the sun in various ranges, visible light as well as ultraviolet A as well as ultraviolet B. So those are called NuLog sensors. It's a company, NuLog, N-E-U-L-O-G. Those are 3 NuLog modules. And if you wanted to do an experiment of some sort to monitor light intensity, which definitely will change during the eclipse, it could look something like that. On the other hand, here's another payload. This particular payload is about the same size, but it's completely different on the inside. It happens to have a camera pointing up and a second camera pointing out. I can see them buried in there. And if I take the lid off, there's a camera. It happens to be a GoPro session camera, this one. And it has an external battery pack just to make sure that it will last for the whole flight. And then also inside the box, there's actually a microcontroller sensor suite. I'm going to pull that out. Again, what you do doesn't have to be this complicated, but here's an idea. This is something that could be done. So this particular sensor suite has a teensy microcontroller, which has an SD card slot built into it, so you can log the data. It has a GPS module. It has an IMU, inertial measurement unit, which measures 3-axis tilt, 3-axis rotation, as well as 3-axis magnetometer, all in that one red chip. It has a pressure sensor. You need to make sure your pressure sensor is good to go down to very low pressures for the stratosphere. And then it has some things that are sort of just user-friendly. For instance, it has a little tiny OLED screen right here, which allows you to see the numbers as well as write them down. But then while you're working on it, you can see what it's doing and make sure that it's doing the right thing. So that's sort of a user feature. It also happens to have right here an XB radio, so it could talk to another unit nearby if that was of interest to you. It has some LEDs to flash lights, again, sort of for user information. And then it has a few different ways to power it. We often just plug in 9-volt batteries, typically lithium 9-volt batteries that are cold temperature tolerant. And then it has a lot of places along the edge here where you could plug in other sensors. So for instance, here is something that took us a long time to develop, but just shows you what can be done. And it turns out that both of these boxes that I've shown you, they have about the same weight. They both weigh about 20 ounces, so just over a pound. And the reason I point that out is for this particular challenge, we will be weight limited. And so my plan is I write the rules. So here's the plan, okay? Allow people to propose to develop something that's in the 1 pound to 2.5 pounds. So let's call 2.5 pounds the upper limit of the small or the lightweight payloads. Or if you really need more weight than that, I would allow you to double it. So maybe from 3 to 5 pounds, perhaps. But of course, if I take on somebody at 5 pounds, I can only take on half as many of those. So you want extra weight, you're going to have to talk me into taking you at extra weight. So there'll be the small payloads, the large payloads. My expectation is I'll be able to take twice as many small payloads as large payloads because there's just an overall weight limitation. My expectation is I'll probably fly these on individual 1,000-gram balloons, maybe up to 5 pounds on each balloon. So that could be 2 small payloads or perhaps a single large payload. And although I will allow people to develop payloads and send them to me, if you're building a big payload, a large payload, I really want you to come with your payload. In other words, I want you to tend to the payload and help recover it. I could use the help, frankly. So I'll fly the payloads for you, but if you're going for the large payloads class, expect to join me on the day. The day is April 8th, 2023. It's a Saturday. And my expectation is we'll fly somewhere in southern Minnesota. So let's go back actually to the flyer and take a look at the second page of the flyer. So here we go, share my screen. Find the flyer, it was up, there it is. Okay, so this is the first page of the flyer. Again, the map here is the map for 2024. And what I'm going to do is I'm just going to shift that sideways. So instead of going over Indianapolis, for instance, it'll go over the Twin Cities. So I'll shift it sideways and both to the west and to the north. In fact, on the second page of my flyer, let's take a look at the map here. So the map here shows me that it passes over Indianapolis, Indiana at 3:06 p.m. Eastern Time. That would be 2:06 p.m. Central Time. So my intention is to shift everything over and pretend that it goes over Minneapolis at 2:06 p.m. Central Time, 1 year in advance of the real eclipse. And that just means that if we want to intercept this eclipse at altitude, we need to launch the balloons maybe an hour, perhaps an hour and a half in advance of when the eclipse is coming by. So if the eclipse is coming by at about 2 p.m., we'll be launching things between maybe noon and 1 p.m. So this will be a middle of the day activity, again, from southern Minnesota somewhere. Exactly where, I can't tell you, because that depends on the weather. We need to predict where the balloons will fly based on the weather of the day, the winds of the day, and then move our launch site so as to intercept this imaginary, literally, but this path in the sky with this eclipse coming by. So taking a look at this slide, team composition, I want people to sign up, okay, no later than the 14th of October, 2022. Turns out that's 1 year in advance of a different eclipse, but we're focusing on the April eclipse. So sign up, you need at least 3 people or up to 8 people on a team. You need a faculty advisor. If you have more than 8 people interested, you could make more than 1 team. And so I didn't actually do the training I mentioned there on October 1st. It turns out not enough teams were ready for the training. And this is not serving as training either. This is a motivational video. But I want people to sign up so we can start having monthly video cons with the teams. And then we will train the teams as they need it. You're developing something, and if you want advice from us about what could work or what you should try or shouldn't try, we'd be happy to provide that. There will be some reports. They might not all be written. I may change my mind about this. There will definitely be a report essentially at the end of fall term in 2022. So December 2022, where you will tell us what you want to do. This is sort of the threshold to get in. I'm not expecting to turn people away necessarily, unless I happen to get way more applications than I can deal with. But this is when you convince us that you have a good idea and you have a pretty good idea how to build it. Okay, so that will be due in December. And then you actually build it. And so in your plan, you will tell us what it's going to do, how it's going to be built, how much it's going to weigh as best you can figure out. Okay. And then by March, so about a month or so before the actual mock eclipse date, it should be done. And I want you to present, possibly as a written report, possibly as an oral report. I haven't decided that quite for sure, but it might be an oral presentation. What you've already built. This is not what you're going to build, what is already built and is being tested on the ground. You want to test it as thoroughly as you can, both for strength and also for performance, possibly even performance in low temperature environments, low pressure environments, the difficult environment that you will encounter when you're in the stratosphere. And then we'll fly on April 8th, 2023, and you'll get your payloads back. The plan is to fly these things and not necessarily have the data come down by radio. You can try that, that's complicated, but rather just log the data, whatever data you're collecting on board, and then we'll recover them and return them to you, and you can look at the data and generate one final report. This is your post-flight performance report. This is where you make your case. Take me to the real eclipse. Look how cool I am. Look how well I did it. Okay, and so you have, in some sense, background information on this flight, and then the idea is you will have that for comparison purposes to the real flight, which will be a year later. So the plan, the flight plan on the upper right is that we'll fly on the 8th of April, 2023. We'll shift the path so that it crosses Minnesota. We'll calculate where we need to be to meet the balloons, have the balloons at the appropriate altitude. The balloons will go up until they burst. So the key is to be high, but not yet burst when the eclipse comes by, or in this case, the mock eclipse comes by. So we want to time these things to intercept the eclipse at altitude. And participants are encouraged to come. In fact, for large payloads, I'm going to make that a requirement that you send at least some people to help out with the launch event. If you have questions, let me know. I hope that you sign up a team. And I'm looking forward to the Eclipse Ballooning Challenge.